Yeah, no, there are three, I think.
Okay, so let's continue our journey through the Android runtime. The next slide is quite dense, if it works.
I don't know.
So maybe when I press up and down buttons, it screws up or something. Yeah. All right, so that's kind of like a picture which highlights of what I was discussing before, right? So you have the source code written in Java, but then the kind of the analogy to JVM finishes, right? Because we're doing some magic depicted by 3 black dots, and we end up with a DEX file. What is DEX file? DEX file is kind of a textual format of how to keep all the symbol links together, links to the code that they kind of refer to, and how to keep the instruction set kind of depicted, right? So it's kind of like ELF, for example, or the exe formats for the binaries. That's sort of like a abstract layer for depicting of how the binary looks like in the VM layer of Android Java. Okay. This DEX file can be generated from other sources not created in Java. So you can use, for example, other kind of JVM languages which will end up in the DEX file. What's the difference between the DEX file and the class file? Well, for one thing, they've used a lot of optimizations. So for example, if you have an interface in Java and you kind of declare it in one class file, then every time you're using it, it's kind of replicated in all the other class files that use it, right? In DEX files, they don't do that. They don't do this duplication of symbol definitions. You have it defined in one section, and then you refer to it, right, by a pointer. So there are some optimizations that they've used to kind of make it more streamlined and smaller. And then the DEX file is combined with the native resources that you have, graphics, images, sound, what have not, and they are packaged up into the APK, right? So the application on Android is kind of packaged up into a single APK. There are some limits on how big that APK can be, and then if you have a game with a lot of assets, for example, and you exceed that limit, you have to split your application into multiple chunks and then publish the chunks independently and have one main chunk which is under the limit being published, and then that one is being downloaded by the user, and then the other chunks are being downloaded by the user when the initial one is downloaded, right? So if you have a big game or big system that exceeds the limit, you have to package it up so then you have the bootstrapping one which is smaller under the limit, and then it will load up all the other chunks necessary for your game to run. But that's done by the build tools and support libraries. So then what you do is you kind of unpackage it again. When you install it, it will kind of install the DEX file and the resources into separate bits, right? Why? Well, then for one, nobody should mess up with DEX, right? It's a read-only data structure, right? You don't want any potential manipulation of what the code is, right? So code, that part is read-only. Resources and native code, well, the native code, first of all, can be, you may need to update it, or you may need to change the resources, or you want to store some things. That, bits of this is read-only as well. So there is a kind of a part which you can update and part which is not updatable. And then the DEX file in itself is unpackaged, and it's kind of, you have the just-in-time compilation step here from the Dalvik VM into the native code, or you have the ELF format, which the art system compiles into the native one, right? So initially we didn't have art at all. We only used this. We only used the Dalvik VM, and we had a kind of a ODEX file format, right? But now we can deal with ELF as well, right? So it's kind of a more, they again benefiting from the from Linux technology to have a more streamlined process, right? So ELF is the kind of binary file format for Linux, right? All the Linux files are using ELF. How much of this you need to know for the exam? Well, not much conceptually. You need to understand what is just-in-time compilation, what is ahead-of-time compilation, what's the relationship between ART and Dolvik. It's a newer version of Dolvik VM, and you need to kind of understand that, you know, Android Java is different to Java. Yeah, okay. So we moving up the layer again. So now we kind of getting into the applications. So that's the highest abstraction layer which we had in the pyramid. And just beneath that, we have application framework. So in the application framework, we have a number of facilities which the application developers are using. So we have, you know, activity manager, window manager, content providers, telephony manager, resource manager, location manager, notification manager, and package manager, right? You don't have to memorize all of them, but you will be dealing with some of them yourself through this course. For example, you will be dealing with the notification manager. You will be dealing with the location manager anytime you're doing something with the location services. We will discuss content providers. You will definitely interact with window manager because you have to display stuff on the screen. And activity manager, there is no way you can avoid that one, right? So by writing the hello world, which is in the lab 1, you already are, you know, activating and using activity manager, window manager, view system, and package manager because you have to install your APK. So you're already touching on 4, right? Okay. Again, why it is important? Well, if you take all those boxes, so if you take the red from the very bottom, the green, the blue, you kind of start seeing like how it has been designed and how it has been organized. So if you kind of go back to the tower, you sort of see how those things kind of fit in together, right? You see how the red layer fits in with the native libraries and kind of the application frameworks up at the top. And it is, from one hand, it's kind of useful when you're programming for Android to understand how things are connected. Why do I need to use location manager to get my coordinates? Because it kind of makes sense, right? It makes sense in the context of this architecture, right? So some developers, for example, complain that Android is complicated. It has all those layers and things are kind of organized in such a way that it feels complicated. Like if I want latitude and longitude, why do I just say, get me GPS coordinates, a single call, which gives me the coordinates, okay? Well, you know, yes, you can have a single call to do that. But then what if you want the updates? What if you want the GPS coordinates to be given to you every half a second, or every minute, or every time someone crosses a certain geofenced boundary? It gets complicated. It's not just one call, right? It is a set of calls. So then in Android, to find this set of calls, to find where it is kind of easy because you know you have to go to the location manager, right? You go to the location manager and all of that is there. It's in one blob, right? If you're working with iOS, they have this one call saying, give me the GPS coordinates. But then when you want to find out how to do something else, it's complicated because it's all over the place. It's like, you know, you don't know where to look. You don't know how to find it. So some things are easy on iOS because there is one call doing something. It's you know, in Objective-C, they have those very long, you know, concatenated names. You know, fetch me this from this URL and put it here, kind of thing. And it's just one call doing it. If you find it on Stack Overflow, great, you know, you solve your problem. But next time you have similar problem, you're starting from scratch. You have no idea where to look, like how to start. Whereas with Android, even though it is kind of a little bit more complicated to start with, you know, okay, everything location related is in the location manager. there is some facade, something managing that for me, right? It really feels slightly different to be doing iOS development and Android development. I'm not saying one is easier than the other. They have their own sort of feel. So iOS feels a little bit easier once you know all the codes that you need. But every time you need something new, it feels so much harder, okay? On Android, if you're doing easy things, they feel, well, why do I need 3 calls? Why do I need to instantiate this location manager? Why I just don't say, get me GPS coordinates? Well, okay, you're doing those 3 calls, but next time you need something similar, it's much easier to find it. It's much easier to get it to work. On iOS, it's a little bit harder to find those calls that you need. Once you find them, they seem easier. So, you know, there is a lot of fights between iOS developers and Android developers saying, oh, it's so much easier on iOS or so much easier on Android. Don't believe that. It's kind of trade-offs, one or the other. So I personally like both. They both have some strengths. So for example, doing UI on Android sucked big time for a number of years, right? So until very recently, they didn't have a very nice GUI builder for organizing your UI on Android, and they still are years behind Apple, right? If you're doing Xcode UI designs, it feels so much better. You have the storyboards, you have, it's really well organized, and it's very simple. And the dynamic layouts, they were there from the very beginning, and they were much easier than Android, okay? Finding things about location and things like that, much easier on Android. So, you know, it depends. It depends what you're doing. There were also some things which were unique to Android. We will discuss them a little bit in a minute once we get to intents. All right, so what we need to remember from that we have those subsystems, that we kind of interact with them, and some of them have a particular manager, which is called manager. It is literally called location manager on Android, right? Which you interact with on the API layer. Yeah, notifications. So Android was always much ahead of time in terms of notifications than Apple, iOS. iOS always kind of copied what Android was sort of pushing. So the notification subsystems for the notifications you're getting on the phone works better on Android than on iOS. And also the cloud integration is much better on Android, naturally, because of Google, right? So if you need to combine your mobile things with cloud, Android is the way to go. Apple really sucks in that respect. All right. So a little bit of a history. You've probably noticed that the releases of Android, they have the kind of the numeric values, which is interesting, right? You know, major version number and the minor with patches. So we were discussing, you know, this famous 2.3.4, which was like a major patch, which kind of, you know, cut off all the crap from all the good things. So everything beyond 2.3.4 upwards is really good. The stuff before, not that good. They try to really use the patch level now for patches. So if there is something more major or some more meaningful, they don't do it on the 3rd number, they do it on the 2nd or 1st, right? That's why between Marshmallow and now Oreo, we had quite quick progression of version numbers, right? I stopped making this slide, you know, 4 years ago because I ran out of space. I'm not gonna do that. You can always click on this link and get the latest version. It has all the history, right? So if I will not do that because it's his laptop, but if you do that, then you see up to 8.1, which is the current one, right? So what's important here is you have the version numbers, the names, the kind of the family names which cover multiple version numbers, and then you have the date when it was released, but you also have the API level, right? So if you go to this to the link, you will see that the latest one I think is number 27, right? And as a developers, we don't care about this number. we don't care about the name, we don't care about when, we care about the API number. That's the thing which really defines the particular version that we refer to, right? So if you want to support a particular version, then you do it by specifying that API level. And every patch increases that level by 1. That's the built-in versioning mechanisms in Android. So the versions in Android are organized by a consecutive integer which goes from 1 upwards, okay? So when you're releasing your app, you have to give it a version number, which will be presumably 1. Then when you patch it or when you do something new, it will be version 2. If you patch it again and do something else with it, it will be version 3, right? It has nothing to do with this versioning that you can give to your users to refer to the applications, right? So the versioning in Android is done by consecutive numbers. So you have 1, 2, 3, 4, and that creates a sequence. So version 4 is newer than version 3 and so on, right? And the way you organize here is up to you. You could call it 0.1, 0.2, 0.2.1, and then this you can say, we have our major one, right? 1.0, okay? So this is up to you, how you do that bit. You know, you can use major, minor, and patch. You can use major, minor, whatever you're doing. You can use names. You have a version string, which is up for your interpretation, for your user's interpretation, what you want. But the sort of the API layer is how your app is actually versioned according to the Google Play Store and according to the stuff that you put in the manifest. So should you jump between the versions? Should after 4 be 6? Well, you should avoid that, right? Because it's a little bit confusing, because there is no 5 then, right? So what if someone refers to 5? It's kind of missing. Every time you upload the version, Google will check if the version is higher than the one you have, right? So it is possible to have 1, 2, 3, 4, skip 5, and then push 6. You can do that. And Google Play will accept that. Will say, okay, 5, maybe the developers released 5 through some other means, right? They didn't release through Google Play. So it's okay to have a hole, but you should kind of avoid it. Here, you do what you want. So as I'm saying, initially Android was using the patch version a little bit more. So for example, 2.3.4 is quite significant. It's really different to 2.3.3, even though the difference is only in the third layer, right? So now they try to avoid that. So they say, okay, if we're doing something major, we will really change the major number. So they're changing here. And then when they do security patches and patches or some minor things, they change this one. And this one is kind of, we will see it's less frequently used these days, the actual patching. All right. So I have a couple of slides generated before because 4 years ago it was kind of more sense to discuss what were the features added and what were the capabilities of the platform. Okay, it doesn't make sense anymore. Okay, so I will skip those slides. I have a small quiz. Anybody knows what this phone brand is? You remember? Yeah? Anyone knows? Yeah? No? HTC, yes, it's HTC. It's HTC. What was the name of this one? HTC Dream. What was this brand of this phone?
It's a G1.
Yeah.
Okay.
So he knows. Again, which brand is this one? Again, it's HTC. HTC played quite substantial role in the early days of Android development. And again, there is a side story that nobody knew about HTC before 2008. It was a company like nobody heard of, right? Who of you doesn't know about HTC? Everybody knows HTC, right? They made their name because they jumped on this very exploratory, unstable Linux-based, open source platform, and they made a number of devices which people used, right? We used those phones in the early courses which we had. Yeah, we were teaching Android early on, like with.
It's HTC Magics, right? Mostly.
Yeah, yeah. So that's HTC as well. That one I don't know. What's that phone? That's another milestone. It was like amazing. Once you get this phone compared to the previous phones, it was like, whoa, it's so fast. And it has this roll ball here you can use as a kind of a cursor control. It was a ball which you could, use to move your mouse around. Who knows what brand is that? HTC. Yes, boring. Okay, HTC was really a strong player in the early days. What phone is that? It's Nexus 1. It's the first Google branded phone, okay? And why it's so amazing? Well, because before that happened, companies didn't have their own branded phone outside of Apple, right? Apple had iPhone, but no other company had a branded phone with that company, and Google didn't have their own phone which they manufacture. They are not hardware manufacturer, right? So they still not hardware manufacturer. They were outsourcing it to HTC. HTC actually developed the phone, but Google branded it. It was a Google phone, right? And it was the first of the Nexus lines. There is a Pixel 2, which came up last year, which is the latest one. I have the previous version. I have the Pixel 1 here. We will discuss that tomorrow a little bit more. So why Nexus phones are important? They are important for two reasons. The first one is pragmatic. Google really cares about Android platform, and they want to have a kind of a flagship phone headset which competes with iPhones, right? They're not doing that the great job. Like, for example, the Huawei phones, the latest ones are kind of much more similar to iPhones and kind of slick. They are slick and fast and so on. But the Nexus lines are kind of good too. They usually packed with quite good hardware. The design, well, you can say, well, it's a bit bulky, and so on. So design-wise, they may not stand out that much, but hardware-wise and software-wise, they do. So what's amazing about Pixel 2 is that it has a hardware support for augmented reality and similar things to what the iPhone X has. It has the structure light and kind of the latest technological innovation that you can play and test between hardware and software, right? So design-wise, okay, we don't compare those, but hardware and software-wise, they are kind of well updated, and they are well maintained, and they always sort of on the cutting edge of the current developments of the Android platform. So if you are kind of a developer into the mobile sphere, Nexus lines are kind of the good to have. If you're really security conscious, Nexus phones are also good to have, because these ones are the first to be patched, and these ones are the first to get all the security updates and kind of the newest features. So this one is Nexus 1. That's where it kind of started, and as you see, it was the first 2.2. And we remember that 2.2 was the first time when just-in-time compiler was introduced. So the phone really felt so much faster than anything which came before that, right? All right, and then, yeah, that one is Samsung, okay? We have some devices. Okay, so one more thing. Android was developing as a platform, and it was deployed on the mobiles, right? So the mobiles were kind of small screen, and the OS, the operating system, was designed to deal with the constraints and the form factors which the headset have. So then, you know, around Android, the 2.3 end of line, something happened. We had more and more tablets, okay? And iPad was gaining more and more market share, and Google kind of thought, okay, we have to have support for tablets as well. Before that, they were using the same OS as was used for the phones, okay? So what's different between the tablet and the phone? Well, I don't have a tablet here, but you know, if that was a tablet and that was a phone, the main difference is the screen real estate, right? If I have something here on the screen and I make it yay big on the tablet, you know, it sucks, okay? So what do you do on a tablet? Well, on the tablet, you can turn it, and I can use that thing on half of the screen, and I have a half of the screen free, for example, to do something else, right? So I have to deal with the real estate a little bit differently. So up to version 2.3.7, we had an activity which was occupying the whole real estate of the phone. And then Google said, well, this model kind of doesn't really work for tablets. We have to have something different for tablets. We have to have an ability for displaying multiple things at the same time. So they introduced the concept of fragments, right? We will discuss it in a moment. And they said, before we roll out this new operating system, we will have a fork. So there was a mobile phone line. They make the fork. They showed people how to use fragments and how to develop for tablets. And Android 3.x, you know, all the lines with 3 dot, which turned out to be just 1, was for tablets, right? So it was a development line for phones. They forked it and they say, okay, this is 2.3.7, which is for phones, the latest one, latest Android for phones. This is 3.0, which is only for tablets, okay? And you could program fragments and different UI for tablets. And then in version 4.0, they merged back and they unified it, and now you have all the facilities for tablets programming in the same line, okay? So that was kind of an experiment which they did to let developers try it out how to program for tablets and give them feedback. So there were two main reasons. One main reason was multi-user support. You know, suddenly if you have a tablet, it might be used in a family and you may want to have multiple users using it, okay? If you have a phone, typically that's not the case. A phone is typically used by a single user. But if you have a tablet at home, you know, your kids will use it, your wife may use it, and you may use it, and you may want to have different profiles, okay? So for the very first time, they thought, okay, we kind of need a multi-user support. So they've added it. And the second thing was this real estate issue. So that's kind of interesting way of them doing that. Apple didn't do that this way. They kind of added the tablet support early on into the same trunk. So they didn't have this kind of fork and merge design. And then there is Android 4.0, Ice Cream Sandwich, again, a huge improvement and kind of the merge with the tablet. So 4.0 is the first Android which supports both phones and tablets, okay? All right, so then we have, again, I'm doing it, you know, as you see from 2012, so it's a historical account of how the market share was. So at the end of 2012, most people were using 2.3.3, okay? Then there was a shift over, and you see here we have the 3.0 and 3.1 were really just developer versions. They were not really released for public, and a lot of manufacturers never used it, right? The only one in the fork which was actually commercially exploited was Honeycomb, which was, I mean, the Honeycomb spans all line 3.x, but the 3.2, okay? And as you see, it was very tiny, right? Very tiny usage of that tablets only OS. And then you have the Ice Cream Sandwich and Jelly Beans. Those were the ones which kind of dominated the market back in a day, okay? So what's interesting here, you have this API layer. So you see the versioning, right? So you see 11 and 12, 3.0 and 3.1 are kind of missing. They were there, but they were not really commercially deployed. So you have a gap here. Yeah.
Probably maybe worthwhile to highlight that Android doesn't release them if they're not commercially used, right?
That's right.
AOSP. So meaning that's why they never saw them.
Yeah, that's right. So if no company is kind of using it, it's not released, right? But you can still download it and play with it as a developer from the developer portal, right? So the other thing interesting here is that you see it is kind of like a double hump distribution, right? So you have your version numbers. Well, this is not really important for developers, but if you are kind of doing a game or doing some decisions about your mobile apps, that's kind of important. So this is your timeline. This is your time. And the time counts in the version numbers which Google releases, right? And manufacturers adapt, right? So we start from the old ones to the newest ones, right? So you see that it kind of looks like, okay, and this is on y-axis we have usage. How many people are using it? What's the importance? So you see that it's kind of low usage, high usage, almost nothing for the 3.2. And then you have another hump, and it tails off, right? So it's kind of a double hump that you have a kind of a drop in the middle. So if we fast forward to 14, this one is a single hump. You have a bulb on 4.1, right? And then it kind of tails off to 8% usage for the KitKat. And here again, you have a sort of small hump remaining around the Jelly Bean 4.1, 4.2, and then a big hump at KitKat. So let's fast forward. Okay, let's do last year. So last year, it's a very clear single hump distribution, right? So if we look at this one, it sort of says, well, we have very huge usage kind of in the middle, and the middle is around Marshmallow, right? So around 6.0. So Marshmallow and Nougat are kind of occupying quite a majority of the space, and then the Lollipop and so on. So it's not small, but it kind of tails off, and then something below 4.1 or even 4.2 or even before 4.4, right? It's very negligible, right? So like around here you have 4.4, and anything newer than 7.1 doesn't exist yet. Almost nobody has 8, right? So that goes almost to 0 at 7.1, right? So the latest API level is 27, and you know, if you are supporting things up, let's say up from 19 or up from 21, you covering majority of the market, right? That's where you set your sort of a lowest supported version. Why would you not set the lowest supported version to 10? Well, the reason is that you will lack some of the APIs which were introduced later, right? And it makes your coding more constrained. So for example, you don't have shadowing on under your images or something. You don't have dynamic animations or something. You're lacking functionality if you go lower than certain level, right? If you go to 21, you have everything that 21 onwards exists from 21. I mean, from 21 backwards. You may not use some of the latest features because 21 doesn't support them, right? But usually what happens is you have them, the newest features, supported by the support library. So I will discuss it later. It's a topic on its own. We will probably spend a lecture on it, how to do the support for the versions and how Android is dealing with that. All right. Yeah, do you want a break or should I continue? That will take me about 20 minutes. Who wants the break? Who doesn't want the break? The rest? Yeah, okay, no break. So we sort of finished the block which was about the Android as a platform, and now we talk a little bit about the main components of what you need to do to make the Hello World thing working. So the Android platform is composed into those building blocks. You have those managers, which we discussed for the application framework, but all of them are using some building blocks which are kind of reused across all them other concepts that are used on Android. And those four are activity, service, content provider, and broadcast receivers. Those are the four fundamental concepts that you need to understand to program on Android, right? Do they exist on iOS? Not really. They are equivalent things which exist on iOS, but iOS uses a slightly different metaphors and slightly different language to discuss how the apps are being developed. So iOS uses MVC kind of pattern. So they have kind of a views and controllers, and they kind of refer to the UI elements as views and to the kind of logic which controls the views as controllers. And they kind of use a slightly different language to operate on similar concepts which we're gonna discuss now, right? So Android is quite well engineered in a sense of setting the foundations for developing more complex things. And those four are kind of fundamental. So we will kind of quickly go through those four things. So what is an activity? Well, yeah, your laptop died again. So one thing is we have to understand that even though the CPU and the memory requirements or capabilities of the phones increased incredibly, right? I mean, this phone is 4 cores, you know, super fast. It's faster than the laptop which I had maybe 6 years ago, okay? So in terms of, and it's like 256 gig of storage and yeah, lots of RAM as well. So, you know, in terms of physical constraints on the resource, we went way up. The GPU is superb, the CPU is superb. So what's the problem? Well, the problem is real estate and battery, right? That's not gonna go away. We want the phones, the apps to conserve the battery usage, and also to you are limited of what you see on the screen. So those 4 components which we see here are kind of engineered in such a way to help optimize for the real estate and for the battery usage. So what is an activity? Activity is a single screen that shows up when you're interacting with the app. So your application is composed of activities which are displayed on the screen. So if you have anything visual, anything interactive in your app, and you have to show it to the user, you have to do it through a single activity which occupies the real estate of the screen, right? So activity is anything that needs to be interfacing with the user. So for example, in the email application, we have 3 activities here. We have, you know, one which shows the list of the emails that you have. The second one, which is the edit box, which allows you to type in the message. And then third one, which shows you the, like once you click on one of the emails from the list, it shows you that email, you can read it. So it's a kind of one thing at the time. Where it comes from? Well, it comes from, yeah?
So a view, so an activity is sort of like a view in the MVC model, and the activity manager is more like the controller of them?
That's correct, yeah. That's correct, with the caveat that the activity and what you see, the activity and the view are now decoupled. So we don't, so like let's say I have my phone and I have an activity running. To display anything on that activity, I have to have the view, and that view is called a fragment. So the activity is just the logical abstract layer which displays the UI, but it's not the UI, okay? It is tied to the UI, but it's not the UI. So like for example, with those three activities, I can kind of switch between them. So I have one, which is the list of emails. I have the other, which is reading the email, right? So if I click on the email, I have the other one here. And then if I say quit, I go back to the list. I have one at the time, right? But with fragments, we can substitute those three things and call them fragments instead of activity and run all of them in a single activity, okay? Because if I have a tablet, I can say, okay, I have a list of emails here, and if I select one, I have it displayed here. So here I have a list, and here I have the view of which one I'm watching right now, okay? So I have email from you, I click on it, and I see it here. If I have it on the phone, I have a list of emails, I click on one, that has to go away, and I see the email, right? I cannot do two things at the time, but on a tablet I can. So on a tablet, the whole thing is just one activity with two views. On a phone, it has one activity with two fragments, and I switch between one visible or the other. Make sense? Okay.
Fragment equals view.
Sorry?
Fragment equals.
Exactly. So the fragment equals view. The activity in itself doesn't really have an equivalent in the MVC model. Yeah, so I have a slide for what I was just hand-waving here. So you get the idea, right? The activity is this sort of the abstract interface between the user and the rest of the app. It has to have a visual component. And those visual components are represented by fragments, right? So I have activity A contains fragment A, and I have activity B contains fragment B. I can have, because activities have the fragment managers, and I can switch which fragment is visible as well. So in theory, I can have these two things running on a single activity. So I can have activity A showing activity A, and then switching to showing fragment A and switching to fragment B when the selection happens. So I can organize my app either fragment per activity or multiple fragments per activity. And in the context of a tablet, it makes more sense to have the views independent, so then I can combine them together in the same activity and display them together, right? All right. Funnily enough, when we started teaching Android, that the fragments concept didn't exist. So it was actually easier because the activity was the view, right? As it is on iOS. And it was kind of mentally a little bit simpler model because you just have the views, well, you know, activities, you populate it with the UI elements, and then you switch between them, right? Now with fragments, it's like you always wonder, should it be an activity or should it be just a fragment? And, you know, there is no obvious way. And then if your app gets too complicated, it gets kind of complicated because the fragment management is slightly different to activity management, and they kind of seem to be doing similar things, especially if you're programming on the phone, right? So, you know, for the phone, I would say, okay, just, you know, forget it, use this. One activity, one fragment, and go on with that, which kind of goes back to the old model. But if you want to translate your phone app for the tablet app, well, then you need to deal with this complexity, right? Okay, one more historical note. Why we do that like this? Well, you know, historically the phones were not as high resolution as this, and the screens were also a little bit smaller. And historically, you could only do one thing at a time with the phone, right? If you see any feature phone with a very tiny screen, there is no way you can do more than one thing at a time, right? So the metaphor was that, okay, we have to have some sort of user experience based on the concept that a user is doing one thing at a time. And it basically, you know, it's sort of like with the original web applications. You kind of you're sort of thinking in the context of onStart is called, and this is called when the activity is resumed. So again, I launch an activity and I have it on my screen. Okay, I press the back button, what happens? Well, the activity goes through the life cycle and on pause is called, right? And the activity is put into a background, right? Because now I'm doing something else. By the way, your home screen is also an activity, right? So when you log in and you see your home screen, that's an activity. And from that activity, you can launch another activity. I can click an icon and launch another one. And then I can press the back button, and the top one goes back on the stack, and this one goes on top, the home screen again. So the one on the back is here, right? And if I didn't use it for a while, if I like press the back button and haven't used it for a while, and Android decided, okay, you know, the user is probably not gonna use it in the next 10 minutes or an hour or whatever, they can call stop and remove some resources again, right? So this can be called. And then the difference between this and this is that if this one is still there, when it's like, when I put it like, then I can go here and put it into background again, right? So when I put it in the background again, on resume is called. But if my activity went to stop, then on start is called. So if I'm freeing some resources here, I need to load them here, and I'm freeing some resources here, I have to load them on start. So you have to match those pairs, right? And then if I haven't used that activity, like, okay, I had some activity, it went back in the back, and I didn't use it for some number of hours. It's the OS decides. Then it may call on destroy and completely wipe it, right? So then if it completely wipes from memory, then what will happen is, you know, on create needs to be called again, right? So the life cycle is managed by the operating system to free some resources and to keep some resources, you know, in the background to facilitate the faster launch of the application, okay? So for example, you launch the game, you loaded all your assets and you're running it, and then the phone calls and you pause the game, the activity of the phone call goes onto the front. Your game can run in the background. It depends on the developers, if they want to pause it or if they want to continue running. Some games, you know, the clock keeps ticking even if you're not in the game. Some games just freeze and wait until you go back to the main, right? So, you know, you have the phone call happening. So then on pause happens, right? So what should you do? Well, typically you just kind of stop the game or free some resources, but you don't free everything, right? That means the user can go back to the game very soon, right? You don't free much. But if this is called, then you should free most of the resources, because it means the user kind of stopped playing for a while, and if you loaded a lot of game assets and things like that, you're occupying RAM, right? So you probably shouldn't. So you probably should free stuff from here. And if you free stuff from here, the on destroy will be less likely to be called if you're occupying very little memory, right? If you're occupying a lot of memory, operating system will kill you first if it needs some RAM. Because it says, oh, if I kill that activity, which is currently not used, I gain, you know, 4 gig, right? Let's do that, right? But if you freed 3 gig and only occupying 1, then you will be competing with other 1 gig apps, which the OS decides to kill, right? So you can kind of play with it. And, you know, it is still a limited resource thing, because even if it can hold a lot of stuff in RAM, the more you hold in RAM, the more battery you drain, right? So the OS is trying to optimize that. So
noticeable how much value you drain from storing stuff in memory?
Yes, it is noticeable. It's not a huge factor for swapping things out, but it is noticeable. All right, so all those calls, all this life cycle, you don't have control over it. Like, it just happens. The operating system manages that. What you have control over is you can put callbacks when the event happens to do something with it, right? So as I was saying, typically when we initialize the activity, we put stuff into on start, right? So we say, okay, when the activity starts, I need to do those things. So you put stuff here. If you're doing something on pause, you have to have an equivalent thing done on resume, right? So if you're freeing something here, you have to open it here again, right? For example, if you are opening a database connection, right? And then on pause closing it, then you have to on resume open it again, right? So the reference to the database connection is valid when the main code happens. Any questions about this? A very similar diagram is for iOS. A very similar diagram for view lifecycle is in iOS. Okay, so services. Activities always have the UI element, but not everything which you will do in your apps needs to have UI. Some things you want to do which don't have the UI, okay? Let's say you want to have, we are using here a music player. You want to start playing a clip, like you want to have an app which allows a user to start playing a clip, right? So you will have an activity for the user to press and select the clip they want to play. And then once they do that, you don't need the UI, right? You just want the music to be playing into the audio stream, and the user will listen to it. And on the top screen, you can have a home screen, or you can have whatever you want, right? You don't need UI while the music is playing. So this logic of playing the music doesn't have to be activity. In fact, it should not be an activity, because if it is an activity, what will happen is the moment your activity goes into a background, the lifecycle kicks in, and the operating system decides, okay, you know, we've not been using it for a while, you know, it wasn't on the top of the stack, I'm gonna call on pause and I'm gonna call on stop, right? You don't want that. You want the thing to keep playing even if it's not visible, right? So you have to make it a service. So the service lifecycle is very similar to the activity. It's also managed by the operating system, but the operating system will not kill your service on its own. You have to kind of indicate that you're not using it anymore as a developer, right? So if a user started playing a clip, you have to, I mean, the operating system has to keep playing the clip until the user or the developer decides, okay, we kind of pausing playing the clip, okay? When it will happen? Well, you know, when a phone call happens, you have to talk. So the speaker has to transmit the phone call activity sound into the speaker. And while your service is playing the clip, and this plays the sound of the call, you get a kind of a messy situation, right? So how Android deals with that? Well, you have various ways of dealing with it. One is that there is an event telling everybody that there is a phone call and they should stop using the audio playbacks, right? The phone call app has priority over anything else to occupy the audio, right? So then you can pause playing the clip in the app. Or you can lower the volume, right? So for the phone calls, you actually are forced to stop it. But for example, if there is a navigation system, so let's say you're playing the clip and the navigation app wants to give some navigation instructions to the user, then there will be an event saying, okay, someone would like for a brief period of time use the audio. Can everybody, you know, lower the volumes for a moment? And that's what happens, right? If you're playing an audiobook and there is a, you know, driving instructions from Google Maps, the audiobook volume goes down, you get the instructions, and then it goes up, right? They kind of negotiate it. Some of those systems are forced. So for example, for the phone call, if you don't react, the OS will kill you, right? And let the phone call occupy the audio. Some of those things are voluntary, right? So if you say, no way, I'm reducing my volume because the, you know, driving instructions, you know, I'm raising my volume, then that will happen, right? So some things are participatory, so the developers have to kind of play nicely with each other, and some of those things are kind of enforced by the operating system. There was a question.
Yeah, why doesn't YouTube use like service for the audio when you stop the YouTube app?
Because YouTube kind of decides that it's a video and audio together. So if you're not watching the video, that means you're not using YouTube, right? If YouTube was audio only, that would make sense, because YouTube is kind of video and audio. The moment the video is hidden, you know.
Yeah, but there's so many times I'm playing a video and I just want to check something else.
Yeah.
I want the video to continue. if it's like
Sure, you can write your own YouTube player, which would do exactly what you want. Yeah, you can do that.
it would be crap.
Yeah.
I really wish there was an audio-only option on the video settings on YouTube.
I think so. I think it makes sense, and a lot of people use it this way. Like my father-in-law uses YouTube as a radio to listen to music, and it makes no sense, right? Should just kill the video stream, and the video stream is just nonsense anyway. So it should be okay, audio only, and then off you go, right?
I know that YouTube worked that way on an older version.
Yeah.
So yeah, but they've changed it. I don't know why.
Yes.
I know why. YouTube's actually doing this intentionally. There's a service called YouTube Red, which is like a premium edition of YouTube. And if you have YouTube Red, the YouTube app will actually not stop playing when you switch on the screen.
Ah, you see?
So it's basically YouTube, Google just saying, okay, if the user
It's a premium feature.
Yeah, if he's not paying money to use our Google Play music service, then he might as well pay to use YouTube as a streaming service. So.
Okay. Yeah, makes sense.
Is it because it costs them less to maintain the activity? Or
No.
I mean,
No.
that's like resources on your phone, not on the servers.
I don't think it costs them. No. Yeah.
I think it's basically because they don't want you to stop watching the screen because they leave.
They
for
push
the
the ads, exactly. Yes. So if you're a free user, they have to monetize on you, and they want you to watch the ads. Yeah. Very good point. All right. So we covered two, right? We covered the activity and anything to do with occupying the visual aspects of the real estate, and we talked about services, things to do in the background. What you can do in the background? You can access database in the background. You can access network in the background. If you need to fetch some feeds, or if you need to download some resource, you do it in a service instead of the activity. You know, if you are creating a running app, for example, which records your distance of how much you walked or run, the actual logging of the distance should be a service, because the users typically switch off their screen. If there is screen switched off, the lifecycle kicks in for the activity, right? You don't want the logging to stop when the screen is switched off. Yeah, by the way, some phones have the GPS hardware hardwired to the screen in such a way that when you turn your screen off, the GPS sensor stops working.
Oh.
So even if you write your app correctly, even if you're using a service, it will still not get the data as soon as the user switches off the screen, right? So in some running apps, like I haven't tested recently, but in the past there was always kind of somewhere deep in the settings an option to keep the screen on. It's dimmed, but it's on just to retain the hardware to work, right? So that's one interesting fact which may trip you over, because it would say, I'm doing everything right. Why there is no GPS data? And well, because the manufacturer decided that if your screen is off, you're probably not interested in GPS data, right? So that's one caveat. The other one, which also I haven't tested recently, it was still like that last year, was that if you turn your screen off, the camera doesn't work, right? Which kind of makes sense for most use cases, but sometimes it doesn't, right? So again, you have to have an activity up in the top level, and you have to have like a preview of the camera feed for the camera hardware to work. Otherwise, the camera hardware will not work neither. The preview noticeably can be just 1 pixel, so you cannot see it, but like as a developer, you kind of have to have a camera preview feeding the video through the screen. 1 pixel is fine for the camera to work, right? So for example, we've been developing a front-facing camera which kind of records your facial expressions while you're doing something on this with the app, right? And that cannot be done as a service, and that cannot be done without occupying something on the real estate. So that actually prevents you developing something which is front-facing, which works on somebody else's app, right? You can do it for your app, that's fine, because you can embed that preview pixel anywhere. But like if you want to do it for Angry Birds, well, it will not work because you don't have access to the screen, right? There are ways around it, but I'm just saying that sometimes some things are a little bit weirdly hardwired between the hardware and the life cycle that may trip you over. All right, so services and activities. 2 more to go. So content providers. This one is quite easy. You know, where can you store persistent data? Well, you can store it down in the file system. There is a, you know, ELF file system on the phone. You can store it in the database. You can store it on the web, in the cloud. Or you can get it from some other application, right? You can have multiple modules and multiple applications doing different things, and they communicate to pass data from one to the other. So then you have this dilemma of potentially having multiple. So let's say you're developing a game, okay? And this is your game. And then you decided, okay, I'm gonna store the high score in the local file, right? So you have the file system, and you're storing the high score. But then you say, actually, you know, I could do that in such a way that I share the score with other players. So instead of storing it locally with the file, I have it through some sort of REST API. I'm storing it on my cloud service, okay? So now I have kind of 2 ways of doing it, the original one and the new one. And then this one is just for local things, for the single player. This one is for the for sharing with other players. And then you say, ah, crap, you know, I really would like to use the Google Play game services and have some achievements and use it with the Google, right? So you have a third one where you sort of are dealing with the Google, okay? And then here you have to write code for all those things, and it's kind of a specific of how you're storing it, right? So this code is specific, and it's kind of hardwired into your app, right? So then you say, actually, this file one was quite crap because it was so much easier if I use a structured data and use SQLite, okay? So then you have to have this logic, and somehow you have to recompile your app and kind of combine it, right? So you say, architecturally, it works, but it sucks, right? What we really want is to have your app kind of, your game is here, and you're using some sort of abstraction layer, some sort of facade, which says, okay, I can store high scores and get achievements, and I don't care how they are done, right? So, like, you would like to have a layer which says, okay, I can have, you know, high score, local one, shared, I can have some achievements, and I don't care how it happens. And then you have this logic done underneath, and it's pluggable. I can have different ways of doing different things, right? So content provider is exactly solution to this. It's this layer. So a content provider allows you to say, I'm kind of a data store which offers certain things, and then you can query me about it, and I will give you the data, and then the implementation details are hidden. It can be stored as a SQLite store. It can be stored as a plain file. It can be stored as a REST API, right? And typically what happens is when you're developing, let's say you're developing some sort of a cloud service, eventually you want to have a RESTful API, but initially you may just dump stuff to a text file for testing purposes, or keep it in memory, right? So those of you who use the cloud, when we were developing the students database, initially we just store them as a table in the memory just for testing that everything kind of works. So you can do that, right? You can store the data in memory. That's super easy to do. Your implementation is trivial, and the rest of your app doesn't depend on the details of the implementation anymore, right? It's abstracted away. So then if you move to the rest, you know, the interface is exactly the same, and that's what we did. We defined kind of a generic interface, the facade, and then the way the data was stored was, yeah, we didn't care, right? And we can swap. We can switch between one or the other, right? So if the user is connected to the internet, well, the REST app works, and we can store stuff over the internet. If the user plays or does something offline, well, we store locally, right, in a file system, or do something, and then use the facilities to kind of coordinate between synchronization between the ways the data is being stored. So if you want to hide the implementation details of how a particular data is kind of being dealt with, you can use a content provider. How does it feel like to use content providers? It kind of feels like doing SQL. So they allow you to have kind of an abstraction layer on top of some sort of data source, and you query it kind of in similar fashion as querying SQL. So you have a cursor, and you say, give me items based on the query, and then you kind of go on with that like this, okay? So, and that's how a lot of built-in services expose their data. So for example, if you want to deal with the address book, with the contacts of the phone, if you say, I want to find a number for Mariusz, then you will use a content provider which Google offers for the contact app. So contact app has the UI, but it also has a content provider which you can query and get records from, right? So when you're developing something and your application is sort of data-driven and you're storing some sort of data, then it usually is a good idea to expose that data as a content provider to other apps to benefit from that data, right? So that's the content provider. So now we have 3. And the final one, again, the laptop stops working, is a broadcast receiver. We've already mentioned that because I said when the phone call happens, there is an event which everybody knows about. How does that happen? That happens exactly through a broadcast receiver, right? If your battery is getting low, the operating system will tell everybody, look, everybody, the battery is getting really low. If you have some important shit, store it in the file, or make backup right now, because in a few minutes or in some time, I will be shutting down the system because we ran out of battery, right? How does that happen? That happens through broadcast receiver. So broadcast receiver is a piece of code which you say in your application, I'm interested in the battery notifications, and if they happen, I want to do this, and you do a kind of a callback. I'm interested in the audio notifications, and if they happen, I will do this callback, right? It's a piece of code where you wire up the behavior to particular event that happens in the platform. You can generate the events yourself as well, right? You can say, oh, I have a GPS location, anybody interested? That makes no sense because location manager is doing that anyway, so everybody will use the location manager for the GPS notifications, right? But you could, for example, say, I know the user is really stressed, right? You may have an app which is kind of biometrically tracking your stress level and announce to all the other apps that you're stressed, right? That would make sense, right? So then everybody else on the phone can register a broadcast receiver saying, I'm interested in this guy's stress level notifications, and if they happen, I want to call this, right? So some of the notifications happen because of the system. So like battery, low RAM, what else? No network or network, GPS. Those happen through location manager. Some notifications happen because the system broadcasts them, and some are driven by the apps which are part of the system. Yep.
Can you say, hey, everyone, I know the password from this user?
Yes, you can do that as well.
Yeah.
Yeah. So if you do that, then you have to publicly announce that you have an app that has this particular notification, so then other apps can register to it, right? And there is a repository where people say, okay, if particular package is installed, then those particular notifications are available, right? So for this notification, they would have to install your app, and then those notifications would be available, right? Yeah, but you can do that. Any other questions? All right, so we kind of covered 4 main core components of the Android platform. We will be using all of them. For the initial Hello World example, we are only gonna use the first one, the activity and the fragment, right? So we're only using activity. So I have to tell you a little bit more about the activities and how they kind of communicate with each other. So unlike iOS, it is quite interesting that Android is a truly open platform. So the discussion that we had, that you can announce to everybody else what you're doing and what you have, is a feature that only Android has. iOS doesn't have that feature. In iOS, if I were to have a notification that, yeah, let's stick to the stress, okay? So if I had, not the cracking password, if I had a notification that the user is stressed, I would have to, in my application, bundle up somebody else's application into the single package and make it run as a single app with my functionality and his functionality, right? I would have to ask the developer to give me the binary or sell me the binary, package it up, and ask the user to install both at the same time as a single app. On Android, I don't have to do that. I can ask the developer to install this person's app and then use the facilities which that app offers without ever touching their code base or asking them for anything, right? It's kind of a distributed way of combining functionality with your code with somebody else's code. And Android is using it all the time, right? So if I open my app and I want to take a photo, I don't have to develop a functionality for photo taking. I can just say, whatever app is here which takes photo, please tell me. And then you have a little pop-up saying, okay, there is this app, camera, this app which can take photo, pick one or use it always. And you pick one, and then that app is being asked to deliver me data that I want for my app, right? I don't have to write a photo capturing app myself to capture a photo. I can just ask on the platform, and all Android platforms, most likely will have something which allows capturing photo, right? So then I ask them, okay, and then what happens is I have my activity saying, I want somebody to take a photo, right? So then I ask Android platform, okay, give me the list of all the apps which allow capturing photo, right? And then I will get the list. I can show the list to the user, or I can make a decision myself, always pick first from the list or whatever. And then I will say, okay, you run, take the photo and give the photo back to me, right? And then what happens is that app will go up front, will do what it's doing with the UI and with the activity, do that, disappear, and then I get the data, either as a link to a file or as a binary blob in the context of taking the photo, right? I never knew how they did that. I never interacted with the developers. It just happens by magic. It just happens by dynamic linking of my code base and my functionality with what's there, right? So it is quite useful, and some things are already built in. So like photo taking is built in, making calls is built in, loading up web pages, showing up the web page. You can use the built-in browser to show a web page. You don't have to embed it in your own thing. You can use what's out there. You can use libraries like OpenCV, for example, has a library app which doesn't do anything. It just bundles up all the OpenCV libraries, which then your app can use, right? So your app loads up and says, oh, I need an OpenCV latest library. And this app says, oh, great, I have one, so you can use mine, right? So you don't have to bundle it up with your app. You can use kind of a shared functionality which is out there. This is unique, and this is only specific to Android. You cannot do that on iOS. So it opens up some challenges because you have to communicate how this is done, how I know that something is available, but it also opens up a lot of, opportunities, right? So, yeah, so this one is talking about the photo capturing. And then you can do the same, for example, for applying filters. if there is if you capture the photo, like you didn't, like some other app captured the photo, but then you can ask, okay, what's out there which allows to do some things, right? So, for example, if you are into photo processing and you developed a kind of a filter app, right? You can develop a filter app which allows people to take photo and do some funny filters or whatnot, right? But you can also do that without the UI at all. You just say, okay, I developed this library, and you build your app and use my library to call me to doing all the filtering, right? So you give me the picture, I will apply the filters, and you do whatever you want with it. So I'm not an end app, I'm kind of like a library app, which people need to install to use your app, right? So then you can sort of benefit from, you know, combining your functionality with a number of developers, which will then use your app, right? To do something on top of what you're doing. So when you're developing a mobile app, you can think, okay, what else can be done with it? And can other people benefit from it? Because if they do, you should advertise all those functionalities. So then say, okay, you can benefit from having my app installed if you want to use something else. It doesn't happen very often, but it does happen. So for example, you can install, I had to install an app, I don't remember for what, but it said to benefit from this app, you have to install the other one, which is for file conversions. This app doesn't do any file conversions, so if you want file conversions, you have to install the other one, right? So then I installed two apps, and then I have kind of a richer functionality, right? All right, so the bottom point here, unlike other programming environments and unlike iOS, there is no main function. There is no entry point in Android, right? Any activity can be launched, and you can specify more than one activity that is launchable from your APK. So if I have a phone and I have an APK from Google Play and I install it, there is a manifest file, we're going to discuss it in a moment, which specifies which activities are the main activities from that APK which have icons which can be launched, right? And then those icons pop up on the home screen, or like not home screen, like the one down below, and then you can launch them, right? So typically one APK has one icon and it's one activity, but you can have more than one. So you can have multiple entry points to your application. So there is no single main function or single thing. It's the user launching the activity, which is the kind of the entry point. And in the manifest, you specify, you know, this activity and this activity are both launchable. They both have icons, the same icon or different icons, different names, and the user can like click and launch it, right? Right. So okay, let me just quickly check. Yeah, so we're getting to manifest. So it's, yeah, maybe 5 minutes. So let's continue. So there is the activity can run in the same process as other activities, or it can run process per activity. Okay. What's the difference? Well, the difference is it depends what you're doing and how the life cycle works and how heavy your activities are, whether you bundle up them into a single process or you split them into multiple processes. Typically, you would like your UI and your services to run in different processes, so then the operating system can kill your UI but keep the services running, right? You can, we discussed this already, you can launch another activity by issuing an intent. And we will spend some time a little bit more on intents in a minute. So all activities, service providers, and broadcast receivers are activated by the intents. So intent is kind of like a message, like a blob, which you send, to the operating system and then to the platform, and then it kind of gets triggered some events. So launching intent will kind of launch an activity or service, and broadcast intent will kind of make the notification across the platform. Content providers, so you see here we're using 3 out of 4 components. Content providers are not activated. They basically are always active. They sit there and you just ask them for the data. So that's simple. You have a very simple API to do all of that. So from the activity, you have 2 calls. You have a start activity and start activity for result. You pass the intent, and the intent contains the information of what should be started, which activity should be started. What's the difference between those 2? The first one starts a new activity and puts it on the stack, right? So let's use the phone. So if I have my home screen, right? So I have my home screen activity kind of currently running. If I press an app, I have a new activity started, and it takes the screen, right? So now from this activity, if I say start activity, the new activity will be started and put on top. So when I press the back button, that one will be taken out, and this one will show up. And if I press back button, I'm back to the home screen, right? So start activity always puts a new activity on top of the one which called it. Start activity for result does the same thing, with the difference that now this activity can pass data back to the one which called it, right? Usually you pass the data into the call, so you can do start activity and pass data to the new activity by bundling it up inside the intent, but you cannot get any information back when this new activity is killed or closed. But with this call, activity for result, when this activity is killed, there is a bundle which is being passed back to the activity which called it. So you can pass the data between. And that's what we need to use for the lab to pass data from activity 3 to activity 2. With services, it's similar. Start service kind of initiates the service. So before you can use the service or make some sort of assumptions that it's running, you have to start it. There is another way, but we're not going to discuss it for now. It's a little bit more involved. We will discuss it later. With broadcasts, you can send a broadcast. You can announce something, and you're just calling send broadcast. So, and then with the querying, as I said, it's very similar to SQL queries. So there is an API how you're doing it. So as you see, this you can, memorize and kind of remember, and it's not much complexity in here. And then we have the manifest file. So the manifest file is an XML document which specifies all the constraints and all the requirements and all the activities and services that you're running in your app. It's typically generated by Android Studio. When you generate like Hello World app, it's generated and you see some sections of it. You can edit it manually by typing XML, or you can edit it in the kind of a visual editor where you say, okay, I want this particular API level and whatnot. I encourage you to use the typing, the raw XML, because then you see how it is organized and how it works. And you have to specify some dependencies as well. So it depends on what your app depend on. You can pre-declare that, for example, you need a camera, and then phones which don't have a camera will not be able to install that app, okay? Some restrictions of usage you can do and manage yourself together with users. Some restrictions you can hardwire to the manifest and prevent the app to be installed, right? If you say, my app cannot be installed on the phone without the camera, then the operating system and package manager will prevent somebody trying to install it. Say, this APK cannot be installed here, right? But if your app requires a camera, but can also work without, you don't put that requirement in the manifest, you just put it in the code and check initially if there is a camera. If there is a camera, you do something, you set a flag, that, okay, camera available. If there isn't, you say, okay, camera not available, we have to do something else, okay? So it's up to you. It's up to the developer, but you have a mechanism to enforce some of the decisions or some of the constraints on the installation and thing through the package manager. Yeah, I think that's it, right, about the manifest. Yeah, so application requirements, we always do that with the API level. Yeah, we don't gonna dive too deeply now into that. There is no point. Use the highest one for the highest. So use 27 for your requirements for your app, and then the lowest one, pick something reasonable. As I said, if you go too low with the lowest one, you will be restricted to the APIs which that lowest one offers. So if you want to use the latest and greatest APIs, then the lowest one has to be quite high. If you say, okay, I'm fine with Marshmallow level, Marshmallow API, I don't need the APIs introduced in 26 and 25, then you can go to 21, right? So, or if your phone is 21, go for 21, right? Otherwise, if you go for 24, you cannot run it on 21 phone. But the highest one should always be the highest. Yeah, all right. So, yeah, okay, so we already discussed that. There is a little bit, one small caveat, okay? So if I have a home screen, now I launched an application. So my activity, this activity runs, right? This activity calls start activity. So let's say this is A1, it's the first activity, right? So this is my home main activity called A1. Now A1 says start activity A2. A2 starts, okay? Now if you want to go from A2 to A1, you know A1 is behind you, right? So what will happen, I need a third hand. So imagine my phone is now here. I have A1 running here, this is A2. And now if you, from A2, if you say start A1, a new A1 will start. And then if you press back button, this one will disappear, you go to A2. If you press back button, you go back to A1, right? It's not desirable. Sometimes it's fine, sometimes it just looks like shit, right? And you've probably seen those apps where you like click back buttons, like you go in circles, right? You go back to back to back to back, it's like, what is going on, right? So that's because A2 called start activity and initiated new A1 afresh on the stack. So now this is A1, this is A2, and this is A1 running in the background, right? Don't do that, right? If you A2 and you know A1 is here, and if you know you want to go back to A1, just say, just kill yourself, just say stop, pause, right? Then you will be swapped and you go back to A1, right? And then if A1 wants to start A2 again, it will say start A2. So you say finish, right? You call finish, which will finish you, go back to A1, start A2, start A3, finish, go back to A2. From A3, don't go start A2 because you end up with a completely new fresh A2 again on the stack, right? And that's why you can clearly see that when you press back button. If you have this mess, and if you are at A3 and you go back to A2 and back to A3, it's like, whoa, something is wrong, right? You've started A3 too many times, right? You should only start A3 once. And when it called finish, it disappears from the stack. And how it happens when it has multiple times? Because if you have A1, A2, A3, and you want to go back to A2 and you called A2, then if you press back buttons from A2, you will not go back to A1, you will go back to A3, right? You getting that? Don't do that. Okay. That's not relevant, so that we can discuss later. UI we will discuss later. There are a number of tutorials, and I encourage you to use tutorials, and if you find some useful ones, put them on the wiki under the tutorials. I've put the Stanford course for Android programming. We loosely follow it. I mean, we have to cover what they cover. We cover a little bit more, right? I don't know how many points their course is, but our course is a little bit bigger. But it's kind of a superset, I would say. But all the technical details are kind of well explained, so you can watch the videos from Stanford. if you're interested, and use Bitbucket and GitHub and Stack Overflow and kind of same stories with all the other courses. I mean, we can teach you some things, but there is a lot of information out there which kind of makes sense to use. So do use it. For the assignments, you probably don't need to quote code that you're reusing. The assignments are written in such a way that you kind of need to do them yourself. We're using specific, naming things. So, activity A1, right? It's very unlikely that you will find code which calls activity A1, right? So you kind of need to do it yourself. But if you find a pattern somewhere, just reuse it, and that's fine. Yeah. What else about anything about that?
I don't think anyone would remember it now.
Usual, yeah. All right. So we will have a break now. Sorry for doing a wrong run with this, and yeah. So let's meet 25 to 12, and we will sort of I will discuss the lab, and yeah, give some hints how to do it, and we will troubleshoot if you still have some problems with the Android Studio. All right. So short break.